This will be for the Econ Assignment, transforming data. Okay, I would like to give you some notes first. All right, so the examples I'm going to use are going to be with a normal distribution curve. All right. So let's say a teacher gives a 10-question test, and the scores range from 0 to 10. Okay, and let's say it was a difficult test, and most of the students only got 5 out of 10 correct. Okay, so the normal distribution curve would basically look like that. All right, so in this case, the mean would equal 5. All right, if it's a normal distribution, the mean and the median are about in the center. So the mean would be 5, and I'm not going to calculate the standard deviation, but you can basically see how spread out the data is. Okay, and now let's say we add 5 to each point. Okay, add 5 to each data point. So instead of 0, 5, and 10, I'll just cross it out actually. The 0 becomes a 5. The 5 becomes a 10. And the 10 becomes a 15. So what is the mean at this point? Well, you can see in the center here, the mean is 10. And you can see the data is no more spread out than it was previously. Previously, it went from 0 to 10. Now it goes from 5 to 15. It's not spread out any more than it was. Okay? So we can say that if you add or subtract from the data, the mean changes, and the standard deviation has no change. Okay? So if you add or subtract from the data to each data point, the mean will change and the standard deviation does not. Okay, now I'm going to use the same example for multiplication and division. All right, so we have our original curve running from 0 to 10 with a mean of 5. Okay, and now what I'm going to do, I'm going to multiply each point by 10. Okay, so instead of 0, 5, and 10, the 0 remains as a 0. 5 times 10 is 50. And 10 times 10 is 100. Okay? So as you can see, our new mean is 50. And I'm not going to calculate the standard deviation, but clearly we can see it's more spread out because before it went from 0 to 10, and now it goes from 0 to 100. Okay? So without even knowing the actual number, we know that the standard deviation increased. We know it went up. All right? So we can make a rule for multiplication and division now. if you multiply or divide each point, the mean changes and the standard deviation changes. Okay? So we said before, when you add or subtract, it's just the mean that changes. But when you multiply or divide, both of them change. All right, let's look at a few formulas. All right, just to refresh your memory, X bar is just the mean of a sample. Okay, and the lowercase s, that's the standard deviation of a sample. Okay, but these formulas, they apply to both a sample data set and a population data set. Okay, it's the same thing either way. So when you add or subtract a constant from each score in a distribution, the mean changes by the amount added or subtracted, but the standard deviation and variance remain the same. Okay, you don't need to worry about variance in this exercise, but for the mean, for the new mean, you just take the original and it's plus or minus whatever constant you added to the entire data set. The new standard deviation is the same as the original. All right, so that's for adding or subtracting. And then for multiplying or dividing, the new mean is just the original mean multiplied or divided by the constant that you applied to the entire data set. Okay, and the same thing is true for the new standard deviation. You take the original and you multiply or divide by the same constant that you applied to the entire data set. All right, so let's look at the Econ Assignment. Okay, so this is for transforming data on Khan Academy. A group of Americans participated in a study that involved taking their temperatures during exercise in extreme heat. Participants had a mean of 104, standard deviation of 2. Doctors analyzing the results prefer to work in Celsius, so they convert by applying the formula. If each temperature is converted to Celsius, what will be the mean and standard deviation of the new temperatures? Okay, so let's start with the mean first. All right, let me see here. So it says the mean was 104. Okay, so I am going to plug in 104. Since we have 104 Fahrenheit, I'm going to plug it in right there. Okay, so that's going to be 5/9 times 104 minus 32. Okay, now this is for the mean. All right, we said for the mean, when you add or subtract, it changes the mean, and when you multiply or divide, it changes the mean. It changes it by exactly how much you're adding or subtracting and by how much you're multiplying or dividing. Okay, so all you have to do is plug it in to the formula. So this is going to be 5/9, and 104 minus 32 is going to be 72. So on the calculator, actually I don't need a calculator. 72 divided by 9 is 8, and 5 times 8 is just 40. Okay, so the new mean is going to be 40. I'm just going to write it down here. Okay, and now for the standard deviation, let's see what happens. Doing a different color. All right, so it says the standard deviation is 2 degrees Fahrenheit. So I'm going to plug in the 2 right there. Okay, but remember, we said before, adding or subtracting does not affect standard deviation. Okay, so even though I'm plugging in the 2 here, I am going to ignore the minus 32. All right, because adding or subtracting does not change standard deviation. So this is just going to be 5/9 times 2. Okay, 5 times 2 is 10, divided by 9, and their answers are in decimal. Let me use the calculator. Actually, I don't even need the calculator. I know it's going to be approximately 1.1, I think. Okay, roughly. They're multiple choices, so I don't need the calculator. All right, let's check out the choices. We're looking for 40 and about 1.1. All right, let me see. So C and D have the mean of 40, and D has the standard deviation at 1.1. Close enough, 1.11. All right, so that's it. All right, the amount of solution a company fills its bottles has a mean of 33, standard deviation 1.5. Company advertises that these bottles has 32 fluid ounces. What will be the mean and standard deviation of excess cleaning solution in milliliters? Okay, and 1 fluid ounce is approximately 30 milliliters. All right. So in order to convert ounces to milliliters, you just have to multiply by 30. Okay, it's times 30. All right, so let's see. The mean is 33 fluid ounces. So the new mean is going to be 33 times 30. Okay, 33 times 3 is 99, and you just add the 0. So that's going to be 990 milliliters. Okay. Remember, for the mean, if you're multiplying the whole data set by a number, the mean changes by exactly that amount. So I just took the mean and multiplied it by 30. Okay, and the same is true for standard deviation. If you multiply the entire data set by a certain number, the standard deviation changes by exactly that amount. So let me see, where's my, standard deviation is 1.5. 1.5. So I take 1.5 and multiply it by 30. And that's going to be 45. And the units are milliliters. Okay, because mean and standard deviation both change when you multiply the data set, all you have to do is multiply those numbers by the constant that you're using. So we're looking for 990 and 45. All right, they got 958. Let me see what I did here. All right, this is an annoying question here because it actually says they want to know the distribution of the excess cleaning solution. All right, so let's see. It's a bad question in my opinion, but let's just go with it here. The mean is 33, but the company advertises the bottles have 32. Okay, so the mean is going to be 33 minus 32, which is 1 ounce. Okay, remember we're working in ounces at first. When you add or subtract, the mean changes. So it's 1 ounce, and then we want to convert that to milliliters. So it's times 30. When you multiply, the mean also changes. So we're going to take the 1 ounce, multiply it by 30, and of course 1 times 30 is just 30. And now the units are in milliliters. Okay, so for the standard deviation, adding or subtracting does not change it. So we're going to keep it as the 1.5. We don't need to do this step because that doesn't change it. All right, we start with 1.5 ounces, but multiplying does change it. So we're going to take that and multiply it times 30. Okay, 1.5 times 30 is going to be 45, like we said before. So we're looking at 30 and 45. I hope that's correct. All right, B is the only one with 30 and 45. So let's see. Okay, terrific. Okay, cargo loads at Neil's Transports in his truck has a mean weight of 42,000, standard deviation of 1,500. What will be the mean and standard deviation of the distribution in kilograms? All right, 1 pound is approximately 0.45 kilograms. So in order to convert from pounds to kilograms, we have to multiply by 0.45. All right, so multiplication affects both standard deviation and mean. Okay, so start with the mean of 42,000. And that's going to be times 0.45. All right, I'll do that in a minute. And the standard deviation, same thing. Okay, standard deviation is 1,500, 1,500, and we are multiplying by 0.45. Okay, so I'll do each of these on the calculator. Okay, I got 18,9 and 675. And those are both in kilograms. So that should be answer A. All right, last one. Mrs. Fitzgerald rents a stall in a mall where she sells antiques. She earns a mean of 500, standard deviation of 125. Her stall and new inventory cost $225 a month and are her only costs. She calculates profits using this formula. What will be the mean and standard deviation of the distribution? Okay, let's see. First off, she earns a mean of $500 per month. Okay. So when you subtract, does it affect the mean? Yes, it does. Okay. So the mean is 500. That's her revenue, mean revenue. That's 500. And her costs are $225. So it's just 500 minus 225. Okay, and that equals 225. So that's the mean, new mean, right? And now the standard deviation is 125. Does subtracting affect the standard deviation? No, it does not, okay? The data is still spread out by the same amount. So this does not change. Subtraction does not change standard deviation, so we're just going to leave it. 125 is your standard deviation. Okay, so 225 and 125. Did I subtract the wrong way? Yes, I did. 500 minus 225 is 275. Thank goodness for multiple choice. 275 and 125. Answer A.